Bonjour, bienvenue sur la chaîne de Mathman. Hello, welcome to Mathman Channel. Aujourd'hui, on continue le cycle de vidéos mathématiques de base en anglais, et ceci est la vidéo 23. Today we continue the cycle of videos Basics Math in English, and today is video number 33. Et aujourd'hui, on va parler des graphes linéaires, et en fait affines, parce qu'en anglais, ils ne font pas de distinction entre linéaire et affine. And today we'll talk about linear graphs. Okay. Graphs of linear equations. Représentation graphique d'équations linéaires ou affines. A linear equation is an equation that does not contain a squared variable such as x to the square, or a variable of a higher power such as x to the power 3. Linear equations can be represented by straight line graphs, where the line passes through coordinates that satisfy the equation. Une équation linéaire, ou affine, est une équation qui ne contient pas de variables carrées, telles que x carré, ou de variables d'une puissance supérieure, telles que x à la puissance 3. Les équations linéaires ou affines peuvent être représentées par des droites, où la droite passe par des coordonnées qui satisfont l'équation. Linear equations. Équation linéaire ou affine. Y equals 2 times x plus 1. Y égale 2x plus 1. Y equals minus 2 times x plus 1. Y égale moins 2x plus 1. And the general form, et la forme générale, y equals m times x plus p. Y égale mx plus p. M is called gradient or slope, and p is the value of y-intercept, the point where the line crosses y-axis. M est appelé coefficient directeur ou pente de la droite, et p est l'ordonnée à l'origine, c'est-à-dire le point de la droite qui coupe l'axe des ordonnées. Finding the equation of a line. Trouver l'équation d'une droite. To find the equation of a given line, use the graph to find its gradient and y-intercept. Then, substitute them into the equation for a line, y equals m times x plus p, pour trouver l'équation d'une droite donnée. Utilisez le graphique pour trouver sa pente et son ordonnée à l'origine, puis les substituer dans l'équation de la droite, y égale mx plus p. Gradient equals vertical distance over horizontal distance. But be careful, we need to check the sign of this distance. La pente est donnée en faisant le ratio distance verticale sur distance horizontale, mais attention, on tient compte du signe. So, let's see that on GeoGebra. Donc, regardons cela sur GeoGebra. Donc, ici, nous avons deux curseurs qui représentent respectivement m et p, donc nous avons tracé l'équation y égale mx plus p. Here we have two cursors, two numbers, that represent m and p. And here we have the graph line of y equals m times x plus p. What we can observe is when m is negative, we've got a line that's decreasing. Donc ce qu'on peut observer, c'est que lorsque m est négatif, on a une droite qui est décroissante, parce qu'on lit de gauche vers la droite. Then, when we have m equals 0, we've got an horizontal line. Lorsque m est égal à 0, nous avons une droite horizontale. And when m is a positive number, we can see that we've got an increasing line. Et lorsque m est positif, on observe qu'on a une pente montante, une droite montante. Okay, let's have some calculation in order to understand the link between the numbers and the graphical line. Donc faisons quelques calculs pour essayer de comprendre le lien qu'il y a entre l'équation et la représentation graphique. Here we have a line with 2 points, A with coordinate is 1, 2, and B with coordinate is 2, 0. So, first of all, we make the vertical distance. If we choose to subtract the height of A over the height of B, it's 2 minus 0, which is 2. And the horizontal distance is made with distance of A minus distance of B. That's 1 minus 2, which is minus 1. So we get M equals 2 over minus 1, which is minus 2. And then we can use a B coordinate, and we can find that P equals 4. Donc, voici comment on a procédé. On a calculé la distance verticale en disant je prends l'ordonnée de A moins l'ordonnée de B, c'est-à-dire 2 moins 0, donc ça fait 2. Et ici, je fais la distance horizontale en faisant l'abscisse de A moins l'abscisse de B, c'est-à-dire 1 moins 2, donc moins 1. Donc 2 sur moins 1, ça fait moins 2. Et ensuite, j'ai utilisé les coordonnées de B pour calculer le P, puisqu'il suffisait de remplacer M par la valeur que j'avais donnée, et j'obtenais P. So, let's make a general rule. Okay, so if we've got a line, we've got 3 cases. First case is, the line is like this. Second case is, the line is like this. And third case is, the line is like this. So we've got 3 ways of calculation, but that's always the same model. Let's assume we have XA, and we've got XB, and we've got YA, and we've got YB. So this distance is XB minus XA. That's the horizontal distance. We call this day H. And this distance is also vertical distance is YB minus YA. So we've got M equals day V over day H, which is minus YB minus YA over XB minus XA. And then we just have to fill the equation and we get P. So I can show you. We've got this, so that means P equals Y minus M times X. So for example, if we use B coordinate, we've got YB minus YA over XB minus XA times XB. I will do it with numbers because too much formula will disturb you. So let's assume this one is 4 and this one is 6. Let's assume this one is 1 and this one is 3. Okay? So we've got 6 minus 4, which is equals to 2. So we've got 2 over here. 2 here. Here we've got 3 minus 1, which is 2. So that's easy, that's 1. And over here, we've got 3 minus 1 times XB is 6, which is minus 3. So we've got X minus 3. Let's go back to GeoGebra and we choose 1, here it is, and 3, and we can have A, which is equals to, we say 4, 1, and B, which is equals to 6, 3. Oh, I said 3, that's minus 3, sorry. Oui, as you can see, it's not on the line. J'avais dit que c'était we can check. J'avais dit que c'était y égale x moins 3 et j'ai écrit y égale x plus 3. Donc évidemment, on ne le retrouve pas. So if I do this, there we go, that's matching. Okay, let's go back and try another situation. Try a situation with the red case. Okay, let's say this one is x b, and this one it's x a, and we've got y a, and we've got y b, which is equals to 0, obviously. Let's say that this one is minus 3, and let's say that this one is minus 4, and here let's say that's 2. Okay, so we can compute the same. We've got m equals yb minus ya over xb minus xa, which is equals to, so which is equals yb 0 minus ya, which is equals 2, over xb, which is equal minus 3, minus xa, which is equals minus 4. So it's minus 2 over 1, which is minus 2. So then we can use the formula for p, p equals yb minus m times xb, and we've got 0 minus minus 2 times minus 3, which is equals to minus 6. So we've got y equals minus 2 times x minus 6. So let's check. So we say minus 2, okay, and minus 6. So let's change this. Okay, let's change this. Okay, so we say b is equals to minus 3, 0. Okay, and a we say minus 4 and 2. Okay, that's matching. And let's try the third case. Third case is if we've got 2 points on this line, let's say for example this guy and this guy. We don't need to know which is YB or YA because they are in the same line, the same horizontal line, so YA equals YB. So we've got M equals YB minus YA over XB minus XA, but as YA equals YB, that means the difference is 0. So M is equal to 0. So then it's really easy to compute because we've got YB minus M times XB, but M equals 0, so it's just YB. So we've got Y equals YB, and as we said, YB is the same as YA, it's a constant. So we can choose any constant. For example, in this case, we can say that's 2. So that's y equals 2. Okay, let's check it out. We say m equals 0, and we say p equals 2. Okay, and we say that b is the same y as a. Okay. Donc maintenant, vous savez comment calculer les équations des droites. So now you can compute equation of a line. See you tomorrow. À demain.